We're diving into the world of nanocrystals today. It's crazy to think that these microscopic particles could revolutionize, well, practically everything, from how we harness sunlight to the very screens we can't seem to look away from. I mean, just think back for a second, right? Those clunky old TVs we used to have compared to the sleek, impossibly thin displays we have today. It's mind-blowing how quickly display technology has advanced. And that brings us to today's deep dive, a 2015 research paper with a pretty intense title, Nanocrystals of Cesium-Lead Halide Perovskites, CSPBX3, X, CLS, BR', and I. Novel optoelectronic material showing bright emission with wide color gamut. Yeah, it's a mouthful, I know. But stick with us. We'll break it down and uncover why this research was such a big deal.
What's fascinating is that this paper came out almost a decade ago, and it really laid the groundwork for so much of the cool stuff happening with displays these days.
Okay, so let's unpack this. First things first. What exactly are perovskites, and why are researchers so fired up about them?
Imagine a material that can capture sunlight and turn it into electricity and do it incredibly efficiently. That's the potential of perovskites. They really shook up the solar cell scene because they hit efficiencies of 20%, which is huge GE, especially when you consider that we're talking about relatively simple, low-cost production methods.
Wow, 20% efficiency. That's impressive.
It is, especially when you compare it to something like traditional silicon solar cells, the ones that have been around forever. They took decades of research to even get close to that level of performance.
Okay, so this paper focuses on a very specific kind of perovskite, right?
Yeah, exactly. See, a lot of the research at the time was on what we call organic, inorganic perovskites. But this paper, they zeroed in on all inorganic perovskites, specifically cesium-lead halide perovskites, or CSPBX3. And the reason that's so important is stability. These all inorganic versions, way more stable. And that's crucial when you're trying to make devices that last.
Got it. So we've got these stable, efficient perovskites,
Yeah.
and then they decided to shrink them down to the nanoscale. Just how small are we talking here?
Seriously small. And nanocrystals are usually somewhere between 2 and 20 nanometers in size. To put that into perspective, think about a human hair. Go ahead, picture it in your mind. Now imagine splitting that hair 80,000 times. That's about the size of a single nanometer.
Whoa. Okay, so these perovskite nanocrystals really are tiny. But what makes them so special for displays?
Well, it's all about their ability to emit light. And not just any light, but very specific, very pure colors. Think of it like this. By simply swapping out one element, we're talking about chlorine, bromine, or iodine, which are represented by that X in the CSPBX3 formula, we can actually fine-tune the color of light that's emitted. And not just by a little bit. We're talking across the entire visible spectrum.
Hold on. So just by switching out one element, you can go from like a deep blue all the way to a vibrant red. That sounds almost too good to be true.
It's true, and it's a huge deal for displays. Because think about it, right now we're using these really complex, multi-layered systems in our LCD and OLED screens to filter colors. But with these nanocrystals, we might be able to ditch all of that and get the color we want directly from the source.
Okay, now that is a game changer. So we've got incredibly efficient solar power potential, these amazing color-changing abilities, and it's all wrapped up in this tiny, stable package. That's a pretty incredible combination.
There's going to be a downside, right? There's always a catch.
Well, you're not wrong. One of the big concerns with certain nanocrystals, particularly the blue and green ones, is that they tend to degrade over time, kind of like an old light bulb. They lose their efficiency, their brightness fades, not ideal for a display.
Right.
But, and this is a big but, this research found that these particular CSPBX3 nanocrystals, especially the blue and green ones, are surprisingly tough.
So that's good news for those of us who are tired of screens burning out.
Exactly. That robustness is one of the main reasons why CSPBX3 nanocrystals have become such a hot area of research since this paper was published. Okay, before we jump into how these nanocrystals measure up against current display technologies, we're going to take a quick break. We'll be right back.
And we're back. Still geeking out over these perovskite nanocrystals. They're like the superheroes of the material world. Tiny but mighty.
And it's not just the colors, right? It's how efficiently and brightly they can actually emit light, which is a big deal for any display.
Okay, so what's the magic word we need to know when we're talking about brightness and efficiency in displays?
Quantum yield, or QY for short. Basically, it tells you how much light you're getting out of a material for a given amount of energy you put in. Higher QY equals a brighter, more efficient display.
Gotcha. And how do these perovskite nanocrystals stack up in the QY department? They're overachievers, that's for sure. We're talking quantum yields of 50 to 90%. That's incredibly high. To put it into perspective, some of the nanocrystals we use in displays right now need this complicated core shell design to reach that kind of efficiency. Perovskites could deliver the same, if not better, performance with a much simpler structure.
So simpler designs, potentially even better performance.
Yeah.
Sounds promising. And speaking of promising, the paper mentioned some other potential applications, right? Not just for displays.
Absolutely. Displays are just the tip of the iceberg. They could revolutionize LEDs, making them even more efficient. And get this, they could even be the key to next-generation solar concentrators.
Okay, hold on. Solar concentrators. Break that down for me.
Imagine this. Instead of those big, bulky solar panels you see on rooftops, you have transparent films on your windows that can power your entire home. That's the idea behind solar concentrators. They capture sunlight over a large area and then concentrate that energy onto a much smaller area with specialized solar cells. And since perovskites are so good at converting sunlight to electricity, they hold a ton of potential for making this a reality.
Wow, windows that power your house. That's next level. You also mentioned earlier about improving LCD technology. Didn't Sony use something similar a while back with their triluminous displays?
You're spot on. Those displays used quantum dots to boost the color and make the images more vivid. Now imagine swapping out those quantum dots for our superstar perovskite nanocrystals, which have the potential to be even brighter, even more efficient, and maybe even cheaper to produce.
Okay, so we're talking about a future with super thin TVs, windows that double as solar panels, and displays so vibrant they'd practically jump out at you. Sounds pretty amazing, right? And you knew there was a but coming, didn't you?
You know me too well.
This research is from 2015, almost a decade ago. And we're still waiting for those perovskite-powered screens to hit the market. So what's the holdup? Seriously, what's the deal? We've been talking about how amazing these perovskite nanocrystals are, but we're still waiting for them to, actually show up in our gadget. What's the holdup?
It's the million-dollar question, right? And while I don't have $1 million for you, I can tell you it's not always a smooth journey from a cool lab experiment to a mass-produced product. There are always challenges.
So it's not as simple as, hey, we made a cool nanocrystal, let's put it in everything.
If only it were that easy. One of the biggest hurdles for perovskite nanocrystals has been scalability. See, the way they make them in the lab, it works great for small batches, but scaling that up to, factory-level production, that's a whole other ballgame.
So making a tiny sprinkle of nanocrystals in a lab is one thing, but making enough to cover millions of screens, that's where things get tricky.
Exactly. Think of it like baking a cake. Your recipe might be perfect for one cake, but can you imagine trying to bake thousands of cakes, all identical, using the same methods? Scaling up production while maintaining consistency and precision is tough. Another hurdle is making sure those nanocrystals can withstand real-world conditions.
Because a super bright, super efficient display isn't that great if it burns out after a year.
Right. Heat, humidity, constant use, all of that can impact a display's lifespan. So making sure those perovskite nanocrystals can go the distance, that's crucial. And then there's the manufacturing process itself. Integrating a brand new material into existing display fabrication techniques, or even coming up with completely new methods, that takes a lot of time, investment, and quite a bit of trial and error.
It sounds like a massive puzzle, and we're still figuring out how all the pieces fit together to actually bring these perovskite nanocrystal displays to market.
It is a bit of a puzzle, but the progress we've seen in the field has been remarkable. There are companies and research institutions all over the world pouring resources into solving these challenges, and we're starting to see some really exciting breakthroughs.
That's good news. So while we wait for our perovskite-powered future to become a reality, what's the key takeaway for our listeners today?
Simply put, we're on the verge of a revolution in display technology. Perovskite nanocrystals have the potential to completely change how we experience the world around us, from our phones and TVs to, who knows, maybe even our windows someday.
It's been incredible taking a deep dive into the world of nanocrystals today. Before we wrap up, what's the one thing you want our listeners to remember about this tech?
They may be tiny, but these nanocrystals, they have huge EE potential. It really speaks to the power of scientific discovery and what happens when we dare to imagine a brighter, more vibrant future.
I love that. And on that note, we'll wrap up our deep dive into perovskite nanocrystals from the lab to, hopefully someday soon, our pockets. Until next time, keep exploring, keep learning, and keep looking for those hidden wonders in the world around you.